All right, so this is the second video with examples of more complicated counting problems. So in the last video, we looked at a couple of examples where we're looking for at least a certain number of outcomes of a certain type. So in this video, we are going to talk about choosing for more than one category, right? So choosing books out of a certain number of fictional books and out of another number of nonfiction books, or choosing restaurants out of a certain number of Korean, Mexican, Italian, so on. All right, so the first example we have here is, suppose you are going to foster, actually I changed it to 3 dogs. Started off as a 2-dog problem, and then I decided 3 dogs would be more illustrative. Okay, so the foster org has 6 small dogs and 4 large dogs to choose from. How many ways can you select 2 small dogs and 1 large dog to foster? Okay, so because we have 2 categories, that means that this is going to be a 2-step fundamental counting principle problem at first. But then, so this is the first part is setting up the 2 steps and using the fundamental counting principle. And then when we choose the small dogs, well, it doesn't matter what order we choose them in, because you're just going to have both of them. They're both going to be getting fur all over your house and clothes, and it doesn't matter what order you pick them in. So here we're going to set up combinations to choose a certain amount from each category. All right, so for our 2 categories, we have small and we have large, and we're going to figure out how many options we have for each and multiply that together. Now for the small dogs, let's just highlight some information about the small dogs. So we are choosing 2 small dogs. So let me just highlight that. There's 6 small dogs to choose from. And then we're going to, out of the 4 large dogs, we're going to choose 1 large dog. All right, so for the small dogs, again, order doesn't matter, so we're choosing 2 dogs out of the 6. And then for the large dogs, we're choosing 4 out of the 1. So you can go ahead and put this in your calculator. I know that choosing 1 out of 4, well, there's only 4 ways to do that, right? So if you forget, you can just put it in your calculator. But 6 choose 2, you can also put that in your calculator. But I happen to know that that's going to be 6 dogs for the first choice, 5 dogs for the second choice, but we've double counted, so we're dividing that by 2. But again, you can just plug 6 choose 2 into your calculator, and so I get 3 times 5 is 15 times, 15 times 4 equals 60. So there are 60 ways to choose with all of these criteria. All right, so first it's the fundamental counting principle, right? So we have the FCP where we have small and large, and then we have our categories are small versus large dogs, of course. All right, so for example 4, the Chinese and the Russian governments are working together to send a spacecraft with 4 astronauts to Mars. The Chinese have, pardon my grammar, the Chinese have 5 astronauts who are qualified to go, and the Russians have 4 astronauts who are qualified to go. Find the following. So A is similar to the last problem. How many ways can they send exactly 2 Russian and 2 Chinese astronauts, right? Because the 2 plus 2 equals the 4, because they want to send a total of 4 astronauts to Mars. And part B is asking how many ways can they send at least 3 Chinese astronauts. And so that goes back to the video before this one, part 1, is breaking it into cases with at least a certain number. All right, but let's start with A first. So how many ways can they send exactly 2 Russian and 2 Chinese astronauts? So let's see, I'll use red for Chinese. It's kind of like the Russians like red too, right? So Chinese, oops, not the pen I wanted. Red for Chinese. The Chinese have 5, and we're picking 2 Chinese out of those 5. And then the Russians, let's use purple. The Russians have 4, and we're also picking 2 Russians out of those 4. So that's going to be one of my choices, is going to be, like, one of the categories is Russian, and the other category is Chinese. And so that's the FCP part where we're saying, okay, the first step is choosing how many, the first step is determining how many ways you can send 2 Chinese astronauts, and then we multiply that by how many ways we can send 2 Russian astronauts. So for the Chinese, we're choosing out of 5, we're choosing 2, and for the Russians, out of 4, we're choosing 2. So plugging that into the calculator, which I'm doing off screen, I'm doing 5, choose 2, and that gives 10. And so then I'm doing 4, choose 2, and that gives me 6, and that's 60. So there's 60 ways to send exactly 2 Russian and 2 Chinese astronauts. Okay, so in part B, how many ways can they send at least 3 Chinese? Well, now we have to break this into some cases. So first we can consider, okay, and let me write this in different colors so it can be more obvious, but here's the case where they send 3 Chinese. And so at least 3 means, okay, 3, that's the smallest number. well, they could send 4 Chinese. Can they send more than 4 Chinese? No, because they can only send 4 total. So these are the 2 cases, and then we're going to add them up. So in this case where we're sending exactly 3, we're going to do the same thing as we did above, but we're just doing it with different numbers. So I'm just going to write CH and R. So in here, for the Chinese, we still are choosing out of 5, but now instead of choosing 2, we're choosing 3. And if we're choosing 3 Chinese, then that means there's only 1 seat out of the 4 left for Russian, and we're choosing that out of 4. And I didn't leave myself a lot of room now, did I? So let me erase these and just color code it for you. So for the Chinese, we're using red. And for the Russians, we're using purple. And then, so that gives us 5. I'll just deal with it. 5, choose 3. 5, choose 3 equals 10. There's a symmetry there. Here, so 5 choose 3 is 10 times 4 choose 1 is going to be 4. And so that is 40 for this case. And so for the next case, we're actually doing 5 choose 4 for the Chinese, and then for the Russians, we actually don't have any room for them. So that means we're doing, of the 4 Russians, not choosing any of them. All right, so out of the 5 Chinese, choosing 4, out of the 4 Russians, not choosing any. So 5 choose 4 is 5. You can do that in your calculator if you want. And 4 choose 0, well, there's only one way to choose none of the Russians, and that's to choose none of the Russians. So we get 5 times 1 equals 5. And so now we're going to add the cases together. So we get 40 plus 5 equals 45. So there's 45 ways to choose at least 3 Russian astronauts. Chinese, not Russian, right? Chinese. And that's basically it, right? So you break it up into cases, and then you have to, figure out, we have to use the FCP and combinations for each case, and then we add the cases together, and you're done. And that's it.